Okay, so we've talked about reference electrodes that provide a stable voltage to compare to. We've talked about one major source of error in any potentiometric measurement, which is the idea of junction potentials that happen at the edges of salt bridges. And now let's talk about how we actually make our measurements. So we need the other half of our galvanic cell. We're going to have our reference electrode, but we need on the other side the thing where we actually measure concentrations. And that's where the idea of an indicator electrode comes. So we have our reference and indicator electrodes. Those combined make the galvanic cell that we use to make our potentiometric measurement. So there's sort of two main classes of indicator electrodes that we're going to talk about. The first are, these are the simpler ones, metal indicator electrodes. These are simpler but more limited in scope. These are generally going to be electrodes where we are measuring the metal ion using the metal of the electrode. I'll explain more in just a minute. The second type of electrode is ion selective electrodes. And these are much more common and much more versatile in the types of ions that they can measure. And I present as one, it's a whole category. There's a bunch of different ways of measuring, making an ion selective electrode. One specific example that's the most common one is the pH electrode. This is an ion selective electrode, and we'll talk about the pH electrode in a later video. But first we're going to focus on number one, metal indicator electrodes. And so the idea here is that we can use, for example, let's say we have a, draw a bigger beaker here. Let's say we have a reference electrode here, whether it's the silver chloride electrode or the saturated calomel electrode that we put into our solution. We attach this to a potentiometer, and then we use something like silver metal here, and what we're trying to do is measure the concentration of silver ions in the solution. And so this silver metal over here, would be our indicator electrode. So this type of indicator electrode relies on the fact that we establish a redox reaction right here between our silver ions and our silver metal. And the potential that we measure compared to the reference electrode is going to be directly related to this concentration of our silver ions, right, according to the Nernst equation, provided there's no other equilibria competing with this or whatever. And so this is basically the basic idea. We could do this with other metals, right? It doesn't have to just be silver. We can use other things. This doesn't work with all metals. One requirement, right? If you want your measurement to not take too long, you want an equilibrium to be established pretty quickly on the surface of your electrode. And so some requirements here. You need a clean surface. It has to be a large surface area for the reaction to take place. Surface area. Because you want the equilibrium to be established very quickly, and that is only going to be true for certain metals, right? So we can write this will be in general Mn plus n electrons going to the solid metal. And so some specific metals that this can work with to measure their aqueous ions are silver, as I listed here. You can also use copper, zinc, cadmium, and mercury is also one listed in your textbook. Though for that, I think you can't use solid mercury, of course, because it's a liquid. You need to use an inert electrode. And this can also work using inert electrodes, as we've mentioned before. Things that aren't participating in the reaction directly, something like platinum or possibly gold can be used to do this. And so this is the basic idea, is that we have the metal in a solution of its metal ion, and we can measure that potential compared to a reference electrode and figure out the concentration. And so this is a pretty straightforward method, but limited in scope. Right, we have a list of 5 elements here that we can measure. We'd like to be able to measure more than just 5 elements, and so we're going to talk about how we can set up a an electrode that provides a potential we can measure using the idea of ion selective electrodes.